Good morning, viewer. Welcome to our Glory Globe TV as a breaking news. Viewers, the warning signs before a major earthquake, if they exist at all, are often buried in thousands of smaller tremors that seem ordinary at first glance. So, the problem for geoscientists is not only finding those signals but knowing whether they are meaningful before the main rupture arrives. Researchers from the FZ also Center for Geoscience, including Dr. Sadek Karim Apoli and Professor Dr. Patricia Martinez Garzon, work with international partners to build a data-driven methods for spotting changes in seismic activity before large earthquakes. Instead of telling a computer what warning pattern to search for, and for the same they used unsupervised machine learning, a type of artificial intelligence that looks for structures in data without being given preset labels. Because the method was tested on several major earthquake sequences whose histories are already well documented, including Khara Manamaras, Turkey 2023, Iquiqui, Sicily 2014, and La Acquia, Italy 2009. In those cases, the analysis detected distinct for shock patterns that appeared weeks to months before the main shock. Viewers, when the same method was applied to earthquake without known precursor signals, including Noto, Japan 2024 and Amatrice, Italy 2016, it did not find the same patterns. So, the researchers argue that this approach could help improve operational earthquake forecasting. The study was published in Nature Communication. Viewers, forecasting when, where, and how strongly an earthquake will strike remains one of the hardest unresolved problems in geoscience. For the same, some researchers even question whether exact prediction is possible. Instead, much of the field focuses on precursor phenomena, meaning changes that may occur before some large earthquakes, and this can include foreshock, which are smaller quakes before a larger one, or slow sleep events where a fault moves quietly without producing strong shaking. So the difficulty is that these signals are inconsistent and their timing, size and locations can vary depending on the fault. So the plate boundary, the local geology and the stress already stored in the crust. A pattern that appears before one earthquake may be absent before another. Viewers, machine learning has already helped geoscientists to work through the complexity of earthquake interactions and search a large earthquake catalogs for patterns that would be difficult to spot by hand. In this study, Dr. Karimpoli and colleagues changed the usual strategy. Instead of beginning with a fixed idea of what precursors should look like, they allowed the data itself to sort seismic activity into meaningful patterns. Instead of searching for specific precursor, we let the data reveal its own structure and make use of so-called unsupervised learning in which diagnostic criteria are not predefined, says lead author Dr. Sadek Karimpoli, scientist in section 4.2 Mechanics and Scientific Drilling at GFZ. Similar unsupervised methods have previously helped detect early changes before landslides and volcanic eruption. Then this exclusive report.